This how-to video provides some hints, tips and tricks to students for when they're completing coursework or practicals involving the collection of gases. And what I've done on the screen is to provide two classic methods of collecting gases in experiments. So let's look at both methods individually and what's good and what's bad about them. Method one is the measuring cylinder over water method, and the type of experiment you normally have with this is typically you put a metal carbonate like sodium carbonate, potassium carbonate, magnesium carbonate into the flask as a solid, and then you remove the bung and put in the acid, hydrochloric acid, sulfuric acid, nitric acid, and what happens is an acid plus carbonate reaction. So normally carbon dioxide is evolved, which comes up the delivery tube, and when you start off, you set this up, you fill the measuring cylinder with water up to here, and when the carbon dioxide is given off, it comes through the delivery tube and bubbles and displaces the water out of the measuring cylinder. And when the reaction's finished, you can read off on the measuring cylinder the volume of gas evolved, and then through calculations you can work out moles of gas and work backward to moles of carbonate and moles of acid, depending on what you're asked for. Now this is normally the opening type of experiment that you will get, and the one that you will do for yourself. And there are a few things which can go wrong with it. So normally the sort of things that can go wrong with this is when you put the acid in with the carbonate, of course that reaction starts instantly, and because it starts instantly, some of the product, being the carbon dioxide, escapes before you actually put the bung in, so you don't get the volume recorded here as large as it should be. The other issue is that carbon dioxide, if we're talking about carbon dioxide, is slightly soluble in water. So what will happen is the carbon dioxide will bubble through here, but some of it will dissolve in the water. So again, the volume of gas collected is slightly less than it should be. So this method has got a few problems with it, or few associated technical difficulties in manipulating the apparatus, which means that the volume of gas you collect normally is slightly less than you would anticipate it should be. So moving on to method two then, this is really a far better method, and it involves a gas syringe. So if we actually look at this set of equipment compared to this, in this case exactly the same type of experiment. We can use a carbonate here, but this time we put the acid into a tap funnel, and here we have a gas syringe, and to start off with, the gas syringe is pushed in. Now the benefit of this, of course, is you open the tap and the acid runs into the flask. You don't have to remove the bung, so none of the carbon dioxide escapes out of the flask before you get the chance to put the bung in, because the bung never comes out. The second thing is that the carbon dioxide goes up through this delivery tube, and this time it's not passing through any water, so none of the carbon dioxide can dissolve in the water. So this method, method two, is far superior to method one. And if you're doing an exam question or a piece of coursework, they may ask you to suggest how, having done this experiment, how you could improve on the experiment to make it more accurate. And this is a method that you could use. Replace the measuring cylinder with a gas syringe, and replace the conical flask with a bung in it and delivery tube to a conical flask, the bung in it, and a tap funnel to run the acid in so that none of the acid escapes. Okay, so that's a little look at two types of method of collecting a gas, and the drawbacks with this one and the advantages of this one. So the next thing I move on to, which often crops up in coursework questions, is the idea of errors and percentage errors. So what I've got here is a typical example of the sort of wording that you would get in an exam question or a piece of coursework. The volume of gas collected was measured using a 250 centimetre cube measuring cylinder. This measurement of volume has a maximum error of plus or minus 1 centimetre cubed. Calculate the percentage error in the volume of gas measured in this experiment. Okay, so how do we go about doing that? What are they actually looking for? Well, here's the kit and the experiment, and just as an example, let's say that we've put potassium carbonate in here, we've added sulfuric acid, carbon dioxide's been evolved, the reaction's gone to completion, and we've got a reading on here, reading 56 centimetres cubed. So how do we go about doing this calculation? And it's really quite easy. We do it like this. So there we go. What have I done? Well, the reading of the measuring cylinder is plus or minus 1 centimetre cubed, and the reading is 56 centimetres cubed, so the percentage error is 1 divided by 56 times 100, which is 1.78%. So quite an easy calculation, really. They often, in experiments or in coursework or in exam type questions, they often ask you to take two readings. In other words, a starting reading and a final reading. Now, if they ask you to take two measurements, what you have to do is you have to double the error. So if I have to read this measuring cylinder's start and then I have to read it at the end, well, instead of it being plus or minus 1 centimetre cubed, I've got plus or minus 1 centimetre cubed in my original reading, and I've got plus or minus 1 centimetre cubed in my final reading. So instead of this being 1, I would put 2 there, and the percentage error would obviously be double this, because there are two opportunities for me to have this error in it. Hope that's clear. So let's move on just to the last couple of sentences about this. Now, this is something to be very careful of. Often you'll find that chemical reaction, such as the one I've described in this how-to video, stop because the reaction is completed. One essential point on this: if something, a chemical in the reaction, for example, if we're using the example I've given previously of potassium carbonate and sulfuric acid, if we add excess potassium carbonate and the reaction took place and then suddenly stopped, what isn't happening is it isn't running out of potassium carbonate, because if I've said potassium carbonate is in excess, there will still be some left at the end of the reaction, so you will still see some potassium carbonate unreacted in the flask. It hasn't all been used up, there will be some left over. The reaction could have stopped because in that example potassium carbonate and sulfuric acid, the sulfuric acid may have run out. So think carefully and look at the rubric very, very carefully when you are answering questions and completing coursework related to experiments where gases are evolved. I hope this information has been very useful. Look at it carefully, think about the messages in there, and good luck. Thanks.